what they're doing. Welcome the speaker.
All right, thank you. All right. You guys ready to get started? I talk too fast. Is that okay? No, you guys are going to say, no, don't talk so fast. But I can't help myself. I tend to talk really fast, but I'll try to slow it down as much as I can. But it looks like there's going to be a recording, and you can watch the recording really slow on YouTube, maybe. That might be an option. But I'll give you a quick introduction to myself, only because I think it's interesting. I've never actually been to Minsk before, and so it's really my first time here. And so I really appreciate you guys inviting me over and the conference organizers getting everything set up. It's always exciting to come out and see a community-organized developer conference because there's so few of those around the globe. Now, the good news is the Java ecosystem is incredibly wealthy when it comes to developer conferences and developer meetups and things like that. But the other languages actually sometimes have no conferences or no real meetups of any strength. JavaScript does okay, sometimes a Python thing here or there, but you guys are very lucky to have something in your home city, which I think is absolutely fantastic. But I'll just quickly introduce myself to give you a little perspective of how odd my background is. We're going to do a technical presentation. Don't get me wrong. We're going to see something really crazy soon. But I actually grew up on a computer that looked like this one in the late 80s. I actually had the dual floppy, right? Because if you had dual floppies, you were really cool. You could actually save your data in addition to running your compiler at the same time. It was amazing, when we had that kind of computer. I actually learned this kind of technology at Pearl City High School in Hawaii. So Hawaii being way out here in the middle of the Pacific Ocean, back in the 80s, they taught me how to write code only because they didn't know what else to do with me. And at that time, no one had any idea that using a computer would be economically viable. There was no jobs back then, okay? You were using computers for fun, and it turns out, especially a personal computer, that you could eventually turn that into a high-paying job. Now, many of you, if you're younger than, let's say, the age 40 at this point in your life, you're benefiting from that moment in time where we actually figured out that if you learned how to use a computer, you could probably get a nice job that pays pretty well and actually, play on the computer all day. But this was my life, right? This is how I learned to write code. I had to actually look out at the beach. From my high school, where I was taking math classes and programming classes, you could see all the way from Waikiki and Diamond Head down to Pearl Harbor. And so it was kind of hard to compete with this, as you guys might imagine, but I did, and I learned how to write applications that way. This was my high school graduation. Does this is what high school graduation looks like here in Minsk? No? You get a lot of leis, you get a lot of, gifts and things like that, so all the flowers are part of this in Hawaii. This is my family, my uncles and my auntie over in Hawaii on the Big Island. So these folks are coffee farmers. My mother grew up as a coffee farmer. She grew up picking coffee beans. And so they were literally coffee farmers, and that's the family that I came from. They still are coffee farmers, other than they're being retired on the Big Island. And this is kind of what their house looks like. It's the tree outside the house. My grandmother grew anthuriums for fun, and of course they had lots of orchids and lots of pineapples. So I just want to give you that perspective just to give you a feel for where I come from. I learned how to code just because it was fun. Now, the good news is you're learning how to code because it pays really well. And so what I'm hoping you see right now in this next presentation gives you some additional education, additional context to help you do something very cool. And I promise you, we're not going to be in slideware mode long. We're just going to introduce this concept, and then I'm going to try to run as many demonstrations of this capability as possible in the next few minutes that we have together. So Supersonic Subatomic Java. This is the concept where we've taken Quarkus, a new open source project that was just born back in March. So literally, this thing is really new. But it shows you how to take your Java enterprise-style programming models and compile it down to native code. So in other words, you can actually have Java code that runs at the same speed as, let's say, C++ code. And this might not sound like all that interesting, because we've actually known we could write Java code that runs the same as C++ code, but I mean actually it fit in the same memory footprint and the same disk footprint, and then start incredibly fast. And we're going to talk about why that's important and when you see it here in this presentation, okay? So the good news about Java, we've been talking about the death of Java for quite some time. This is my Mark Twain Duke, if you guys are familiar with the famous quote, the reports of my death are greatly exaggerated. Today, Java's old hat, look at that date, 2006. We've been talking about the death of Java for over 13 years at this point. It's kind of amazing. We still talk about it all the time. But Java's doing incredibly well. If you look at the TIOBE index, the Red Muck index, as well as the Hacker News here, Hacker Rank, I should say. Java's doing incredibly well. JavaScript's doing well too, so is Python. Others are doing well, but Java's doing incredibly well. And so there's still so much goodness in this ecosystem. There's still all these frameworks, and it's a full ecosystem full of tools and capabilities and libraries that you take advantage of at this point. And these things are amazing, and they keep Java so viable. But here's the challenge. When it comes to all these libraries, all this technology, all these frameworks, Java's kind of put on a little bit of weight. And I don't mean Java, the language, or even the JVM per se. It's when we start building enterprise applications, we start jamming in all this additional stuff. And we started taking advantage of two cool features in the language that have been out there for a while. One is dynamic class loading, and another is reflection. We would do, dynamic class loading, load whatever at runtime, from disk into memory, do the annotation scanning, and of course, that took time, and it added weight. It adds weight that you actually can never get back unless you recycle the JVM. And many of us in the Java community, especially who've been building enterprise programs for quite some time, we know that recycling that JVM is important, meaning restart the JVM so we can get back that memory, or restart the JVM because we ran out of threads in the thread pool, or connections in the connection pool. So that's always been a kind of a thing inside the Java community to think about it that way. And of course, Java keeps putting on weight. Now, this wasn't a problem. Back in the old days, we, as Java people, we owned the computer. If you guys remember that, we owned the whole piece of hardware back in the day, all right? So we would buy a Sun Solaris machine that was built like this. It was like a small microwave oven, or actually a washing machine, if you're familiar with that. It was actually about this big. It looked like R2-D2 or something. And we would use that, and it had, let's say, 4 CPUs and 2 gigs of RAM, and we would use the whole thing. And we could. That's how our programs were built. That's what Java was built for back in the day. But when we put this thing in this new thing called a container, a Linux container, and we try to lock it down, it actually has had some problems. So with Java 8 in particular, you might have noticed that when you actually set up your Java application and put it in a Linux container, it would blow up. And by default, it does. If you don't treat it carefully and you try to lock it into a Linux container, basically the Linux kernel is going to look at that Java application and go, hey, you're outside your memory boundary. You're outside your CPU boundary. Let's shut you down. And so the funny thing about that is in Kubernetes, it restarts it automatically. So you see these JVMs getting restarted all the time in a Kubernetes-based architecture and a Linux container architecture. And you're probably thinking, oh, well, at least it restarted. I don't know why it stopped. And I've had managers tell me, this is brilliant. My programmers write bad code. If it restarts automatically, I don't have to have an operations team restarting that JVM all the time. But it actually shouldn't have to be restarted, okay? The real challenge, though, is when you start putting these things in lots of containers, it's hard to manage all of them. One JVM is easy to manage. 20 or 40 or 50 JVMs is a much bigger job to manage, okay? If you also look at these quotes right here, and imagine some of these are kind of hard to see, but I actually did look up, and you can find this online, right? If you want to run Java in a serverless way, in a serverless architecture like Amazon Lambda, you'll find comments like these on the internet. Well, what does it take to run Spring Boot in a Amazon Lambda? Why? And the comments are like, why would you ever do that? You should never use Java in an Amazon Lambda architecture. You should never use Java with serverless architecture. You should only use JavaScript or Python or Go or C++ or something like that. You'll see this time again. And when we gave birth to this Quarkus technology, you can actually go look on the Reddit thread where I was debating with this guy who basically was just astounded that Red Hat would make any investment in Java. Why would you ever do anything for Java? It's dead, okay? So that is definitely not the philosophy we've had at Red Hat. We believe that it's fundamentally valuable and incredibly important to the ecosystem. So this is where we introduced Quarkus. That's our Supersonic Java. The concept is we've been making it work in the form of 10 times faster, 100 times smaller in many cases. So it's vastly lighter weight than the Java that you had before, but for enterprise-style use cases, and that's the important thing. So we'll look at it here, but I want you to go back to 1999 for a moment. And in 1999, this is what it used to be to stand up a web server, a web application. For those, how many people here build web applications of some sort? Most of you, right? Well, it cost you $500,000 to build a web application just 20 years ago. Now, many of you weren't programming 20 years ago. I was. And 20 years ago, I had to go to customers, because I was a consultant, and say, I need $500,000 to get started. Just to get started. Hello World was $500,000. There was no cloud back then. There was no virtual machines back then, right? You had to buy real big old real computers, normally from Sun, and you can see the prices of the 2 Sun machines. You had to buy BA WebLogic, you had to buy Oracle, you even had to pay for your IDE. The IDE is $50,000. This is long before there was an Eclipse, before there was an IntelliJ, and before IDEA, became free, right? So you had to pay a lot of money for that. Now, I want you to make a look here, though. Instead of paying $500,000, you now pay only so many cents per hour, maybe 5 cents an hour, 20 cents an hour, but you are now paying for that memory and CPU that you're using. So what this has done in this cloud world that we're in is made us conscious of the fact that memory matters, CPU matters, startup time matters. It didn't matter in the old world where we had $500,000 of hardware. It didn't matter. We owned it. It was one JVM, one $500,000 piece of hardware. It does matter now, okay? That's kind of the point. So there's also some really cool features in Quarkus related to the developer, and you're going to see this. We're just going to show it to you. But the concept of how a developer can be more productive using a live reload feature, how we've married a reactive and imperative programming model, how you could use Java for a serverless architecture if you choose to, and I'll show you an example of that. And of course, if you just want to run Java and microservices, no problem at all. Okay? Also, we focus very heavily on making this thing work for Kubernetes. My session tomorrow will be on Kubernetes, so you'll see a lot more Kubernetes stuff there. We'll show you just a little bit here. But the concept of running application workloads on a Kubernetes cloud-native way allows me to actually scale my applications very easily. But again, you're now very focused on how much CPU is this using, how much memory is this thing using. So we'll keep going. This is the world of microservices. You can see we've been thinking about microservices now for several years. If you actually look at it from the perspective of when Java was born, way there at the end, 1996. Here, I'll just zoom in here. Okay? You can see Java was born back in 1996, but the world has changed since then. Linux became a big deal back in 2000 with Red Hat Linux. You might see FreeBSD jails, right, which is the kind of the beginning of the concept of container-type architecture. The Agile Manifesto back in 2001. Amazon with EC2 born in 2006. So KVM in 2007. DevOps 2009. So we've been thinking about these problems for quite some time. Okay? So you can kind of see microservices really being born in 2014 as far as the term goes, based on things like the popularity of Docker or Spring Boot, Kubernetes really coming into the foreground at that point. So we've been thinking about this problem for quite some time. This is not a new problem. It's just that we've tried to wedge Java into this space, and we've been learning a lot about it. So while Quarkus is a very new project, it does come with a lot of learning that we've had over the last several years. We've been working on Kubernetes since its inception at Red Hat. And at Red Hat, we call that thing OpenShift. If you guys have OpenShift, that's Kubernetes. And so we've been thinking about it, and we've come up with a solution. Okay? Here's actually the world of the containers. If you think about jails back in 2000, right, you can kind of see where things like Solaris Zones in 2005, the user namespaces in 2008. You can see C groups as an example, and of course, Docker and Kubernetes being born here in 2013 and 2014. So a lot of things have happened in this world, and we've been working on this project for quite some time. All right? And then serverless has also been out there for a while. Look at Amazon Lambda, born in 2014. I just give you that little bit of history so you guys have some context about how we've been thinking about these challenges for some time. All right? But let's go ahead and show you this. I want to go ahead and show you Quarkus as opposed to talking about Quarkus. So it has a faster boot cycle, faster boot time. It also has a much faster startup and much lower memory footprint. But let's kind of show you this thing. It's much more fun if we show you. So I'm going to go here and go to Quarkus.io. That's the website right there, Quarkus.io. And I'm going to say, get started. And I'm going to read the guide. And I'm going to take this one command from here. I'm going to basically just run this one Maven plugin, copy paste that out. And I'm going to come over here and say, make, dir, and we'll just call this Minsk. Okay, Minsk. There we go. Run this command. And this is just going to prompt me for some things. So I'm going to say com.burr Sutter. And let's call this Minsk. And then let's call it the Minsk project. And we're going to, yes, and rest, and good. All good there. I'm going to bring up my IDE, which is Visual Studio Code now. I don't know if you guys have used Visual Studio Code, but if you use Java with Visual Studio Code, we have, just going to show you what that is right here. Red Hat did the language support originally for Visual Studio Code. You can see there's 17 million downloads of that. So if you're not using Visual Studio Code, I'd encourage you to check that out. It's an awesome lightweight IDE. and I prefer a lightweight IDE to the heavier ones at this point in time in my life. I was always more of a programming editor kind of person than a heavy IDE kind of person. But this is my little application. You can see it dropped an endpoint in there for me automatically. Let me bring up the terminal. So as a developer, I've now got my project started. I've got it loaded into my IDE here. I can say Maven Quarkus dev to throw us into what's called the Quarkus dev mode with live reload capability. It starts the debugger by default. And now let's go in here and check this out. So I can come here to say localhost 8080. And I can also check out the hello endpoint that it was added. Make that a little bit bigger. And if I want, I can change the code now. Well, let's not make it bonjour. Let's make it more interesting. That aloha. How about that? Save. You hit refresh, and it automatically reloads. So this programming model right here is already kind of unique. For a Java person, you're not used to doing the edit, save, refresh, right? Typically for a Java person, you do edit, save, build, reload, refresh in some form or fashion. And so the concept of being able to change anything and just hit refresh in the browser is more of like a Node.js programming model. If you're familiar with Node.js, the Node people have had this forever. As Java people are like, wow, that's new and cool. But it's, Java people, we like to do big builds, right? We like the big Maven build, things like that. But it's not required here with the Quarkus Live mode. So I can come here and make a change. And I can even look at my testing here. Let's close this down and come over here. So you can even run test. So let's just go and run this test. It should fail because we've changed it now from hello to aloha. So now we have got a little red X here. And we can see that the test has failed. Okay, because it says hello and we got aloha back. We know that. So we can fix our test now. Aloha. There we go. And run the test again. So I'm still, just kind of interactively interacting with this code, and that keeps it very straightforward. So that's hello world. You guys are probably thinking, that's not an impressive. Well, let's do something a little bit more interesting, because this is not a real-world application. It is nice that it's REST out of the box. It uses JAX-RS out of the box, right? That's all good. But let's actually kind of make a real application of this thing. Let's come over here, back over here, and let's do this. Maven, Quarkus, list extensions. If I can spell extensions correctly, did I misspell it there? Oh, no, I got it right. And let's make this a little bit smaller. All right, Okay, what we're going to do is we're going to add some extensions to this. An extension is a library that's gone through the Quarkus process. So it's like a library you might be familiar with, like Hibernate as an example. And so let me go over here and grab Hibernate, but I'm specifically going to grab one called Panache. And we're going to show you what Panache is. It's basically like it's Hibernate, but Hibernate made easy. Okay, and we're also going to get Json B for Json Binding. And let me also come up here and grab, let's see, what else do I want? The key cloak. Oh, I'm going to make this a PostgreSQL application. Oop. Let me add another comma there. All right, hit return. All right, very good. And let's now. So what it did is when I ran that command, it updated my POM XML. You can see that my POM XML right here now has REST Easy, it has REST Assured, it has JSON B, has PostgreSQL. And so this is important to understand. When I say compile down to native, we're going to compile this thing into a native executable. Okay? That means no JVM required to run this thing any longer. At this moment in time, though, I'm running it in a JVM mode. That's what live reload is. So if you want to go interactive, then JVM is awesome. And it's also, if you want to run the JVM just straight up, it's still smaller and faster on a regular JVM. It doesn't have to compile down to native. But we're going to go ahead and just kind of interact with this thing in a JVM mode for now, and we'll show you what it means to compile to native in a second. All right, so let me bring up my dev mode again. Now that we have our POM XML updated. And let's come over here. I want to make sure I'm in the right place. And let's add a new file, todo.java. All right, class. We're going to add let's go to make a new entity here. So this is a JPA entity right there. And the one thing I'm going to do is extend Panache. Extends Burr. Okay. Panache entity. Okay. And then I'm going to say public string title. So let's say that's all I need for my application, right? So this is my entity that I'm going to persist into the database. Let's hit save here, but I'm going to make another change, and that is to my resources. Where'd it go? Here we go. application.properties. And this is where I need to set up the configuration to connect to the database. I have this over here, so let me copy that in. Okay, we'll just kind of paste that in, and you can see it's fairly straightforward. It's a standard, kind of JDBC style connection. You got to have your PostSQL driver, Postgres driver, and of course whatever user and password you want. And you can kind of see there's also the Hibernate specific, drop in create if you're familiar with Hibernate, and also log out SQL. But let me go ahead and change this to Minsk as the database name, and I'll even just make it super simple for myself. Make the user ID and password the same. Okay, hit save there. Now let me go into my user interface for Postgres. And what I need to do here is build a new login. Okay, so let's call this Minsk. And it has a password of Minsk. We'll just go ahead and open up all the privileges just to make this super easy. Okay, so it has the full ability to kind of create all the schema. Let's create a database, call it Minsk, and make the user ID Minsk, and hit save. Okay, so that, in theory, is a fairly straightforward operation. Let me hit refresh on my browser, which reloads the application. And now let's go in here and drill down on this database, schemas, public, and tables. And there's now a to-do schema. So if you guys see that right there, it generated the schema for me automatically and added it directly to the database. So I have my to-do application, but I have hardly done anything, but already with Panache and Hibernate, it's going to go ahead and make that magic happen for us. So if I want to come in here now and say, okay, let's add a little bit more to it. Let's add a public boolean completed, and let's add a public int order. Now, order is one of those types of names, so it can actually cause conflict with the database. So let's go ahead and actually fix that, and we'll say name equal ordering, and hit save there. And we got to get import for the. Come on. Import the column. Here we go. Come on. For the annotation. There we go. Very good. And actually, let me show you this too. Let's say I have an error. So one thing you notice, it's dynamically compiling and also checking what our code looks like. So in this case, I have an error in the code. So syntax errors, not only are they seen in the IDE, they're also seen in the browser. So that's a massive win by itself for those people who kind of worked in that world. But now if I come here and refresh, all right, let's go back over here and look at our schema again and columns. And you can see there's the 4 columns we've added. Okay, so that's a simple way to build an entity, and that's actually very straightforward, but it gets more interesting than that. Okay, let's come up here and really blow this thing out now and do something interesting. So to-do resource, resource.java. I'm going to build a new class here. Okay, now this is going to be interesting. This is going to be the REST endpoint that actually talks to that entity. So we want to do a path, and we're going to put this on just the root path. All right, root path. At produces, we're going to produce the type, and there we go, dot application JSON. Fantastic. And we're going to consume application JSON. Didn't mean to do that. Go back here. Dun, 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 dun. Okay, and my path, I've got to get that. Nope, come on, import that path. Import the path. And consumes. There we go. And there we go. Let you go ahead and pick. All right, so basically we're just importing our annotations, and now I can do something interesting like this. I can say get. I can say let's go with a public. We're going to return to-dos. Actually, let's return a list of to-dos and get all. And all right, return to-do.listAll. So here's a convenience method provided by the Hibernate Panache capability. So basically, I'm going to list them all. And again, I have to get my import correct. And you can see there's the Java util there. All right, very good. And let's hit save. And again, that edit, save, refresh. Now let's go back over here to root. And you notice there's this page that comes up by default. So this is an index HTML that we provide out of the box, just to kind of give you a feel for what that little application is doing. I don't have to keep this thing, though. So let's go ahead and move it out of the way. I'm going to go back into, I'm going to just use Finder. And you notice I didn't take the server down or anything like that. It's still up and running. What I want to do now is, where am I at? We're in Minsk, okay? And so source, main, resources, NINF, there's that index HTML. I'm just going to go ahead and delete that one, get rid of it. And I also have the other from To Do MVC, which is an open source project you may have heard of. I'm just going to take the user interface from that. So this is all open source code that is already out there on the public internet. So I'm just going to grab that, dun, 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 and drop it in here. Paste that in. And so now we should have an empty list, right? So there's nothing in their database, so it's empty. And I also have a user interface called To Do HTML. Okay? So you notice it's just, again, move files around, edit files, refresh. So it's a fairly straightforward process, right? That's kind of the goal of this, to basically allow it to be incredibly interactive. And let's see, what do we want to do now? Let's go ahead and put in a post. Okay, and actually, let's make this transactional. I'll go ahead and just know that it has to be transactional. And let's do a public, and we're going to do a response, add, and we're going to add a to-do item. Okay, looks good so far. And so we're going to say item.persist, and then we're going to do a return response, and then it's going to be okay. Yep, we're going to return the item status 201 build. If I did that right, we got to basically make sure we get imported here. Dun, 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 imported, there we go. Fantastic. So let me hit save there. And if I did this correctly, let's see, 2, 3. Let's see if that kind of sort of worked out for me. If I come over here now, I'm going to hit refresh over here on the database side and view all rows. Let's see, what do we have? 1, 2, 3 in the database. All right, so now I'm adding records to the database. I could use a curl command or something like that, but the user interface is basically doing that post for me. And so this kind of interaction model allows you to basically build an application pretty quickly. So I've now have the add. Let me add a delete. Let's add a delete here real quick. And then I can also make that transactional. And let's do public response. We have a response for this. And delete one. And we're going to delete the, I know what I need to do here. Add path. And we got to have a, let's go, we have to have a place to hold that ID. And let's see, at path param. And we want the ID. And that's going to be in a long value called ID. Oh, right. Okay. And so we want to do a to-do entity equal to to-do.findById. So again, those convenience methods are already built into that object. And I can say I want to do an entity.delete. And then let's do a return response status. Okay, so I think for that, I think it's a 2 of 4, okay, that we want for a delete. Okay, let's see if that worked out okay. So again, we have to kind of refresh. Boom, boom, boom. Notice how it happens when I hit refresh. All our data is gone. And that's because right now, I have this thing set up for drop and create. So let's go ahead and change that. Drop and create is awesome, but once your schema is kind of settled down a little bit, you can go into update mode. So we'll change that. So even changing that parameter, it results in a refresh. So response to refresh. So 1, 2, 3, 4. Let's go in and check out our database again. Refresh here. And view all rows. Let's see if we have 1, 2, 3, 4 in the database. Fantastic. Right down here. You can see them. OK. And let me come over here now, and let's see if my delete works. I may have messed something up, but we'll try it. OK. Remove those. And those are gone. So just 1 and 4 are left. So we have a delete now, and we can continue this process, right? This interactive process. Let me try one more. Let me get a little fancy here, and we'll see if this works for me. Patch, because patch is what that user interface uses. Transactional again, and you should notice that this is a transactional system, so this is actually a real transaction to the database. Oh, actually, let's do this. Let's make this a little bit faster. Patch works almost like delete. Let's just grab that, and let's call this to update. Okay, and this will get a little bit fancier though. To-do entity equal to, and this one actually sends a to-do in. Let me add that. So to-do, to-do, find by ID again. There we go. So we're going to find one, and then we're going to update it. So we're basically say entity dot completed equal to item dot completed. We're going to say entity dot, not ID, we'll do order, okay, equal to item dot order. We'll say entity dot the title, right? That's the thing that the user is typing in, item dot title. And then we do entity dot ID, which will equal to the ID that came in as a parameter. And then we return, let's see, response again. And we'll do OK, entity, the entity we updated, status, 200, build. So if, in fact, we get a nice edit done there. So let's see if this works. So that's a little bit fancier. Basically, we're going to be able to update now. So if I hit refresh, okay, it still says 1, 2, 3, 4. And let's try to update it. And 1, and hit return. Let's go check our database. Let's refresh this, and it's 1 and 1. Okay, so now I have a lot of different options now. So I have 3, 5. I can do a lot of different things. I can delete, and let's delete that one. So love Java, learn Quarkus. Whoop, I got to spell that correctly. Dun, 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 dun. And let's go look at our database again, double check on it. And so that's, a fairly working little application. So this is what we do as an average enterprise developer, right? We get data from some form of API, some form of user interface. We drop it into some form of database, typically a relational database. It might be a Mongo database, a MongoDB or something like that. And we get data out of the database, and we put it back in the UI or API. That's what we do all day, every day in the average big banking application, big insurance, big government. It doesn't really matter where you work. This is a fairly standard programming model that you guys are constantly working in. Is that fair so far? Don't most of you do this already? And you're probably tired of it. We call this CRUD, create, read, update, delete. We call it CRUD, though. It doesn't sound very nice. But let's say that's what we want, right? I could come up here and get a little fancier with it. We could add annotations to do validation on the entity directly. Like for instance, we want this to be, not null or not blank. I can make sure that it's no longer blank. You can't enter a blank one, things of that nature. I want to make it unique, etc. But let's leave all that alone for now. And what I want to do next is do this. So let's come back over here to Minsk. And I want to show you this little trick. Okay, so we built our little application. I can compile it now into a regular old Java application. Package. All right, so we're going to just do a Maven package to basically create a standard everyday JVM-based application. Nothing weird here. It looks like I know why I have an error there, because now that I'm kind of going into production mode, I need to go ahead and switch this back. So let's go. Update is great when you're kind of interactively with it, but let's just use drop and create. So we got that built. Maven package. Let's go and build it one more time. Maven package. All right, let's do that one more time. And now we have this, again, it runs our test, so it's a good thing I got the test updated correctly. All right, target. And now in our target, you can kind of see there's this runner.jar. Do an ls-a. You can kind of see it's, 11 meg. So there's one thing that's kind of unique about Quarkus versus, let's say, other what's called a fat jar architecture. So if you're familiar with Vertex or Drop Wizard or Spring Boot, which is how we've been doing it for the last several years, typically they load everything into that one jar file. That actually is not the most performant way to do it or the best way to do it when it comes to Docker images. Because when it comes to Linux container images, those are built in layers. So you don't actually want to put all your infrastructure code in your business logic code when you don't have to. So we actually separate that here, and you kind of see there's this lib folder also. Let's do this. And you kind of see there's a lot of stuff going on here. Well, let me do it this way. The lib folder, so this is one thing to keep in mind. The lib folder has to kind of go along with you. There's the infrastructure code that was created. So this is the stuff you normally deal with when your Spring Boot application, your Drop Wizard application, whatever it might be. Typically, this is all the stuff that actually makes things like listen to HTTP or actually make JPA work. Hibernate, as an example, is in there. So we're not going to worry about that for now. Let's go do java-jar. Well, let me do ls real quick. Let me make sure I get the jar name correct. Java-jar. And this one right here, target. There we go. Run that. So we're running it now in pure JVM mode. You can kind of see it started in 1.3 seconds, connected to database, set up connection pool, get default schema generated. So I can come over here now, and let's go back to our little application. Hit refresh. Okay, so so Minsk, hello, world. Okay, so we got connected there again. Let me hit refresh, just double check it. And so what I'm doing with the database right here might seem a little weird, but this is because I am old school. I like knowing that the data I think I saved actually made it to the database. Okay, so I'm constantly going back and looking at whatever it might be, the MySQL interface, the Postgres interface in this case, to say, oh, did that data really make it in there? It looks good. Okay, let's close that down. And so when I mentioned earlier that we can compile this down to native, this is what that looks like. So Maven Package -p native. So this actually means some magic is about to happen. And I want to kind of walk you through what that magic is, but we're also going to show you some other things while that's occurring. This process actually does take a little bit of time, okay? Because it's actually doing a lot of optimizations, and it's also doing dead code removal to ensure that only the things that have to go in that native executable are going in there. So even the JVM itself, or the Java libraries that you're used to, get shaved down as well. So everything gets whittled down to its core essence. And so let me see, I have some diagrams here to kind of talk about this a little bit. So our Quarkus architecture, we don't want to load it up that way. Let's load it up in Firefox. Here we go. All right, so this is the core architecture, the way to think of it. So Quarkus core sits on top of things like Yandex and top on Gizmo, and also leverages this thing called the Graal VM, right? Graal VM SDK. So that is basically part of the process that's going through right now, is to basically say, let's compile this Java application into a native executable, remove all the dead code we don't need, just simply optimize for those Quarkus extensions that have been optimized for compiling down to native. So what we've done is we've gone into things like Hibernate, and we've removed things that aren't necessary when you go native. And here's another way to think of it. If you're familiar with Hibernate at all, like if you don't connect to an Oracle database, you still have all this stuff in Hibernate belongs to Oracle, if that makes sense. In other words, I'm connecting to Postgres, not Oracle. Therefore, all the Oracle stuff needs to get the hell out of Hibernate. That's what this process is. Okay? I don't need the Oracle stuff in there any longer. I only need the Postgres driver and the Hibernate capabilities that belong to Postgres at this point in time. I only need the things that my code will, in fact, call. If it's not called at all, it's removed from the runtime executable. So you can kind of see there's a bunch of different extensions that are out there, and this list is growing all the time. If I go back to Quarkus.io, you'll see the list of extensions is growing every single couple weeks. We release this every 2 to 3 weeks, and you can kind of see there's a bunch of core technologies that are out here, things like Netty. There's Kafka capability. There's Vertex if you want to do that. There's Kubernetes-specific things, Amazon Lambda-specific things, and actually the engineer working on Amazon Lambda on Quarkus is here at this event. His name's Justin. You'll see also Sebastian talking later today about how to secure your Quarkus-based applications with this thing called Keycloak. So you can kind of see there's security capabilities, there's observability capabilities, so there's Keycloak. Okay? All these things are part of those extensions that have been quarked, right? Quarkized, meaning they've been made to compile down to native. And so you can't not necessarily pull any library off the shelf out of Maven Central. You have to kind of pull one that you know has been optimized for this ultra lightweight, ultra fast startup. Okay? And it's actually easy to build your own extension. You'll see that in the extensions world. Let's see here, is it miscellaneous? There's a whole section on how to build your own extensions. So it's actually under guides. So while that's testing your application, configure logging, writing your own extension, okay? And also, so all that has been documented, so you guys can also contribute your own extensions. As I said, this project's only been around for about 2.5, 3 months. So there's a lot of capability that's already out of the box, but we recognize there's stuff that you might have or might want that you can bring as well. So you can look at this extension capability and understand how to write that for yourself. What else do I have here? Let's go here. Open this up. Come on. Open it up. Firefox, right? Okay, so this process of doing this compilation of your application.jar, it's going to go there and basically assemble it into an actual native executable. It might be done at this point, so it is, all right? Let's go here. So this is it right here. So, let's see what this guy is. So everything, including everything it needs from the Java ecosystem, everything it needs from a Java enterprise standpoint is all in that one file. And so I can kind of now say Minsk and run it. Notice it started in 0.031 seconds. And there's another thing that's different about Quarkus than other libraries or other tools and frameworks that you'll see. Most people will basically talk about how fast it is to load the JVM. And so in other words, all that's happened is just a JVM has started, or just how long it takes to load your framework on top of the JVM. This is the time it takes to hit the first response, okay? So in other words, it's ready to go. It's not one of those things where we're lazily loading things in the background over time. It's not lazy loaded, right? It's optimized from the very get-go. So that thing started already. Let's come back and check my user interface one more time. Hit refresh. Of course, it drops everything. So love Java again. Learn Quarkus. Be awesome. All right, and maybe we love Java already, so check that one off. Come over here to my database. Hit refresh. Dun, dun, dun. There we go. View all the data. Let's see what we have here in the database. And there it is. And you can see love Java is checked off as true. Okay, so that updated went in as well. Okay, I know we don't want to run out of time. We only have about 10 minutes left. There's actually a bunch of other things I want to show you. But let's just kind of jump back here in slide mode to give you a feel for that. So if you look at it, a REST endpoint is about 10% of what it was normally in previous frameworks and previous ways of thinking about it. So in other words, instead of 140 megs of RAM, we're down to 13 megs of RAM. If you're dealing with REST plus CRUD, which is what I just showed you here, 35 megs of RAM versus 218 megs of RAM. So dramatic reductions in size as well as dramatic reductions in speed. So if you think of it like this, we start in 0.014 or 0.055, and actually the one I just started was 0.036. So you can kind of see the startup time there versus the startup time of a traditional application, which might be 9 seconds, 10 seconds, 20 seconds. Now, again, this might not mean that much to you. You're like, well, I can get coffee. That's what developers think, right? The build is running. So even that little live code thing I just showed you, you're probably thinking, I'm not going to have coffee anymore. That's when the build is running, is when I go get coffee. There is that problem. We can expect coffee sales to tank universally around the globe at this point. And my people are coffee farmers. I mentioned that earlier, right? So you got to worry about that. So, but what I want to show you now is this concept. Why does this small and fast really matter? And let's see if we can make that make sense. Yeah, let's come over here. Oh, so let's actually just tell you this just to be on the safe side. So this is a Kubernetes-style architecture. Kubernetes has this concept, and we'll do the Kubernetes thing tomorrow, but Kubernetes has this concept of the master node that is managing a bunch of little other nodes that work like one big computer. So basically, that's the nice thing about clustering technology. You basically can take a bunch of smaller computers and make them look like one big computer, and we basically can run our applications across all those nodes in that cluster. So something is run like this Tomcat or Spring Boot app or Wildfly or SQL Server. It doesn't really matter what it is. It can run it across that cluster. And you kind of see that we have 2 replicas right here. So that means I want to remove 2 things out to that runtime. With Quarkus, you can run maybe 20 of those because of that 10x boost in terms of size. Right? In other words, if I can reduce things 10x, I can run 20 instead of 2 in the same memory footprint. And that matters when you're paying for that memory over at your favorite public cloud provider. In other words, these are real dollars being saved, okay? So just keep that in mind. Now, let me show you what we have here, though. Let's control this, and let's see if I can make this make a little sense to you. Dun, dun, dun. I have a Kubernetes cluster I've set up. We're going to come over here, okay? And I'm going to just show you something. We'll give you the details on this tomorrow when I talk more about Kubernetes. But I just want to kind of give you a feel for how this works. So here's my Kubernetes cluster. It's OpenShift running on Amazon, okay? And if I could get to I don't have time to get to the Amazon pieces, but basically it is a bunch of VMs, virtual machines running on Amazon right now. And actually you can see that in our new user interface here. You can kind of see the machine sets, all projects. So you can kind of see basically I have 2 of this type right here running in Paris. And then I have 1 of these. So I have 4 worker nodes right now, 4 computers that are all kind of bound together in a Kubernetes way to basically talk to them as one big computer, if you will, to move my applications out there. And I can say stuff like this. I can say, let's come up here and look at this now. Notice there's no pods running. So pod is the unit of work in Kubernetes architecture. Pod is the computer, if you will. So that's where my JVM runs. That's where my Node.js runs, my Python runs, my C++ runs, whatever it might be. It runs in this thing called a pod. And I don't have any pods. Well, let me actually show you the pods. I don't have any pods running at this moment. But here's what happens. Let's say we have a burst of load coming in. So let me do that. I'm going to basically send in a ton of load into the application, and I'm going to do this first for Node.js. Okay, so this is a Node.js application put under extreme load, and what we're using is something called Knative, which has this dynamic scale capability that looks at the type of traffic you're getting, and you can kind of see right now, there it goes. It's trying to get those three things started from nothing. So we refer to this as a cold start latency, and the user is waiting, the first user is waiting until that pod gets started. And that includes everything that is needed to fulfill the request. So it sent 40 requests in. It took 18 seconds to get to that response. Okay, so 18 seconds. That's not bad. But that's what we talked about when we showed you earlier, that you have to wait a period of time, then that time matters. Let me try another one. Let's actually do Quarkus over here. And by the way, the pods now show up here. There they are. So there's the pods right there in the user interface. And I can look at the details of them. So we'll come back to those pods in a second. And actually, I want to do this real quick. KN polar. Yeah. All right. We're just going to basically have a polar go out there and interact with those endpoints. And these are all public endpoints, by the way. If we wanted to, we could let you guys touch them. But let me also run Quarkus. So basically, same thing as before. And actually, the system is under load already, right? So we're starting Quarkus with that penalty, if you will. But it kind of runs just like Node.js does now. You can kind of see there's our first response from Quarkus, and it took 16 seconds. So 2 seconds shaved off what it took for Node. Because here's the point. With Quarkus, you Java programmers have the better speed than Node.js developers now, both in terms of development and runtime performance, and it's smaller than a Node.js application with that natively compiled application. So let's go do this. Polar. I'm just going to run my polar again. Notice what's happening too. With Knative, it's starting to shut down things that are not being used. So this is that serverless architecture. It dynamically scales out quickly with a burst of load, but with low load, it starts shrinking those resources, giving that memory and CPU back to the overall cluster. So it already shut down 3 of my Node.js applications, and it'll shut down these Quarkus ones, the ones it sees that there's not enough load to keep them up there. So we can come back over here now and see, here's my Node app. Let's open that one up. And there we go. See, my Node application is currently running about 92 megs of RAM and on that system. And let's go over here and check out our Quarkus one. So 92 megs of RAM, and I should mention that a lot of that has to do with the fancy stuff that's built into Knative. So Java, 83 megs of RAM. So we shaved 10 megs of RAM off of the application just by going to Java with Quarkus, obviously, because regular Java would not do that. I mean, if I want to, I could also kind of show you that I have Go, right? Same kind of process. Go, of course, is super tiny. But we've been working, when it comes to Go, we've actually benchmarked that if you use Go with ORM, basically Quarkus is the same size and speed as Go with object relational mapping and things like that. But you can see there's my Go application coming online. And then if I come over here, I can say, let's do this one. Yeah, one more. I'm just basically just throwing a lot of load at these things so you can kind of see it auto-scale up. So there's yet another application coming online. The Go application took 19 seconds. So you can kind of see they're all about the same when it comes to cold start latency, at least at this point for that Go, Node.js, Python, Quarkus application. And let's go check this out. But you can kind of see, again, there's that Quarkus application. Then there's I got a lot of pods running now, but look at all these things that have just been started on this cluster, which is kind of fun, which is kind of the Kubernetes way of thinking. Let's see here. Let me run this again, because it timed out. It took a little long on that. Yeah. Okay. So this is a traditional JVM-based application as an example. But that is kind of the concept that I want to talk to you guys about today, right? You can kind of come in here and see now, hopefully, with this dynamic scale capability, leveraging the cloud from the perspective of what does it take to run all those things in the public cloud. You want your cold start latency to be low. You want to be incredibly fast. You want to be as small as possible because you're paying for all those megabytes. So your users are paying for startup performance because they have to wait, and you are paying for every megabyte that you use in the public cloud. Okay, so let's come back over here now and make sure we cover this. This is just going to be my last closing slide, and we're out of time, I know. But I like to think of this as just the beginning. This is a project as open source, just was born back in March 2019. You guys can start getting involved with this project now. There's already one gentleman that's running around here, basically has pushed an application into production on Quarkus already. So he wrote a blog about it and actually did some tweeting about it. So he basically took his existing application, because you saw what it looks like to program in this world, moved it over to Quarkus, compiled it, and actually has it running. So I know I'm out of time, but is there time for a question or two? Yeah?
We're running out of time. Let's leave a time for one question.
One question?
Yeah.
So it's got to be a great one. Way back in the back there, he's going to say, how much does it cost? And I'm going to say, it's free, it's open source.
Thanks, Burr. Great talk. Last time I checked GraalVM and native image. As I remember, web servers built to native image were like twice as slower than warmed up JVM. Well, due to just-in-time compilation, I think. So, how's things are going now?
If I understand your question correctly, I'm just kind of looking how things go here. All right, so if I understand your question correctly, yes, if you have a warmed-up JVM and you have a long-running process with a large heap, you may find that JVM mode still performs better than a natively compiled application. Okay? But this architecture here is based on microservices. It's based on the dynamic scale out of the cloud. You actually don't ever really have warmed-up JVMs that last weeks or months at a time anymore. You have JVMs, in this case, lasted all of 90 seconds approximately. So it depends on the type of architecture you're building. If you have a system that you're going to stand up and leave running for weeks on end, then JVM mode might be better than GraalVM-based compiled code. And so, but the good news is with Quarkus, you're still faster and smaller with a JVM, and you're still faster and smaller on native. All right, well, thank you. That's a very fair question. And I'll be around for questions after the fact if we are in the middle of a coffee break now.
Yep. Thank you, Burr. Let's say thank you to the speaker. Yeah, please feel free to reach to him in a coffee break, and we can have a coffee break.
And if anybody wants the slides, that's the link to the slide deck. Thank you.